Hello everyone, my name is Teo Heng Yang and my matrix number is DD2081, and for this video I will explain for the part of introduction. So firstly we can see what is the first heat transfer definition. So heat transfer is a process by which internal energy from one substance transfers to another substance. Thermodynamics is the study of heat transfer and the changes of that result from it. An understanding of heat transfer is crucial to analyzing a thermodynamic process, such as those that take place in heat engines and heat pumps. So for the form of heat transfer, conduct of three main points. So under the kinetic theory, the internal energy of a substance is generated from the motion of individual atoms or molecules. So heat energy is the form of energy which transfer this energy from one body or system to another. This heat transfer can take place in a number of ways. So firstly, you can see for the conduction is when heat flows through a heated solid through a heated current moving through the material. You can observe conduction when heating a stove burner in element or a bar of metal, which goes from red hot to white hot. And the second one is convection, is when heated particles transfer heat to another substance, such as cooking something in boiling water. And the last one is radiation, is when heat is transferred through electromagnetic waves such as from the sun. So the radiation can transfer heat through empty space, while the other two methods require some of method contact for the transfer. And the objective of heat transfer is a wide range of application can be performed using heat for industrial scale operations. For the second one is energy used in industries is primarily by electricity and steam. And the third one is to avoid heat loss, it is necessary to know how heat is transferred. And the last one is effective and economical designs are easier to achieve with knowledge of heat transfer. And for your information, you can see the effect of heat transfer, which is the basic effect of heat transfer is that the particles of one substance collide with the particles of another substance. The more energetic substance will typically lose internal energy, which is called cool down, while the less energetic substance will gain internal energy, which is called heat up. The most blatant effect of this our day-to-day life is a phase transition, where a substance changes from one state of matter to another, such as ice melting from a solid to a liquid as it absorbs heat. The water contains more internal energy. The water molecules are moving around faster than in the ice. In addition, many substances go through either thermal expansion or thermal contraction as they gain and lose internal energy. And the last one is water and other liquids often expand as it freezes, which anyone who has put a drink with a cap in the freezer for too long has discovered. And the heat capacity is mean the object help define how the object's temperature respond to absorbing and transmitting heat. Heat capacity is defined as the change in heat divided by the change in temperature. And the law of thermodynamics in heat transfer is guided by some basic principles which have become known as the law of thermodynamics, which define how heat transfer relates to work done by the system and place some limitation on what is possible for a system to achieve.
For the conduction means heat can be transferred between particles of matter without the actual particle moving. For the result, the particle at the fork tip will shake as a result of receiving heat energy, Once it happens, the metal screw will fall off the fork. For the conclusion, from the experiment, we can conclude that the main particle of metal start to move more quickly as it gets hotter. Therefore, we can logically conclude that the heat is transferred from a hot region to a colder region through a solid medium.
Assalamualaikum warahmatullahi wabarakatuh. My name is Kamarul Noham bin Kamarul Hisam. My metric number is DD 2073. Today I'm gonna do convection experiment. First, convection is heat transfer process involving the movement of a heated fluid such as air or water. So to do the experiment, first we need 2 cups of water, which is filled by hot water and cold water, and a flat cover to cover the water, and lastly food coloring to differentiate between hot water and cold water. So the result is the hot water instantly rose to the surface. The hot water immediately rose up because the hot water and cold water mix, because hot water is less dense than the cold water, so it has expanded and risen. Thank you.
Ladies and gentlemen, Assalamualaikum warahmatullahi wabarakatuh and greetings. My name is Muhammad Zarfan bin Rosman and my matrix number is DD 2087. So I am proudly represent myself as a member of Group 13, and for today's session I would like to conduct an experiment called radiation. So before we proceed to the experiment, some of you might think what radiation actually is. So from what I have learned, radiation is a process, it's a heat transfer process where heat energy, heat waves are emitted that may result in being absorbed, being transmitted or reflected by a colder body. So the example for radiation is the heating Earth by sun. So you guys might have no idea what I'm talking about right now. So without wasting any moment, let us jump to the experiment. Radiation. Right, for the first radiation experiment today, we are going to use this stove right here, and just 1 spoon and a bucket of ice. So this experiment is very simple, but make sure kids, if you watch this, make sure you are under your parents' supervision, because this is very dangerous, because you are going to play with fire. So the first thing that we have to do is we just turn on the fire. Okay. Right. And what I'm going to do is I'm going to put my hand right above the fire. Make sure you don't move it too closer because you might get your hands burned. Alright. As you can see right now, I'm not even touching the fire, but I can feel the heat. So this is one example for radiation. You guys might not feel it, but you guys might not see it, but I can feel it right now. My hand is pretty hot. So in order to make it obvious, let's use this bucket ice right here. So what I'm going to do is I'm just going to put this ice right above the stove right here, and you can see this ice is slightly melted. So that's all for the first experiment. And for the second experiment, we are going to use this lovely microwave right here, and also we are going to use the same bucket of ice that I used before. As you can see right here, the ice is in a solid state. So what am I going to do next is I will put this ice right into this microwave and heat it for about 2 or 3 minutes, and let's see what's going to happen next. I put it inside and heat it for about 2 or 3 minutes, and let's leave it for a while. So ladies and gentlemen, since the 3 minutes has passed, so we are going to see what really happened to the ice after 3 minutes being heated in the microwave. So let's take a look. Right, as you may see in this glass, the ice has completely melted. Alright, so the reason why everything happened in experiment 1 and experiment 2, there's a reason behind it, and I would like to give a detailed explanation on how the ice melted and how the radiation affect this result. So I'll see you in the next video. Let us move on to results. So radiation happens when heat moves as energy waves, called infrared waves, directly from its source to something else. This is how the heat from the sun gets to Earth. In fact, all hot things radiate heat to cooler things. When heat waves hit the cooler thing, they make the molecules of the cooler object speed up. When the molecules of the object speed up, the object becomes hotter. In both experiments, the radiation is adding energy to the ice. However, part of the energy is transferred right through to the water. Furthermore, heat radiation has a little effect on ice thickness. Rather, this form of heat transfer has greater effect on ice density. It turns solid ice into what it is commonly known as liquid. Next, the heat waves is traveling at the speed of light, resulting in warming my hand. Before I end my turn, I would like to make the whole conclusion for radiation experiment. As we know, thermal conductivity is an extremely important material property that enables thousands of production systems to function properly and efficiently. Heat is constantly being exchanged within every ecosystem in the form of lost energy. Harnessing thermal energy to use for industrial and practical process has created excellent energy-saving technologies that are utilized daily. One of the most important examples of radiation heat transfer is the Earth's absorption of solar radiations, followed by its outgoing thermal radiation. This process determines the temperature and climate of the Earth. That's all from me. Thank you.
And for the last part of the video, we can conclude what we have done for this heat transfer project is thermal conductivity is an extremely important material property that enables thousands of production systems to function properly and efficiently. Heat is constantly being exchanged within every ecosystem in the form of lost energy. Harnessing thermal energy to use for industrial and practical processes had created excellent energy saving technologies that are utilized daily. Conduction, radiation, and convection are the different ways heat can move through a system. Structure, density, and material composition are factors that can impact the thermal conductivity of a sample. Materials with high or low thermal conductivity values are used for a variety of everyday applications. And lastly, although highly underestimated, life will not to be the same without heat transfer and thermal exchange. Thank you.